When you have followed my channel, you will surely know that I was busy with this chip. It is a 12-stage ripple counter, and these are, say, the most important pins. And this is, of course, 8 goes to minus. This is, by the way, a drawing of an earlier video. I will give the link in the description. I was struggling with the stability and finally found a solution after, say, studying, doing more experiments, and the solution was very, very simple. We have, this is the circuit, by the way, we have here the so-called override pin or reset pin, and when that pin is not connected to the minus, the chip, the memory, the chip is not able to push the signal, the pulse, to the final outputs, output 11 and output 10. So when you connect the reset to ground minus, it works very, very stable. And that's why I made this setup, and now you surely can see that the circuit works stable. I've also made a clock, by the way, clock circuit here. I will tell more about it, but you can surely see that this works okay. So now it's time for the more funny experiments that you can do, that I can do with this chip. You can surely see that the signal is pushed through, say, the buckets of charge, and finally to that output 11. I'm not sure at the moment how this exactly works, but my idea is that there are approximately 3 or 4, perhaps more, sequences where the clock fills the buckets, and after that 4th sequence, or perhaps a higher sequence, the whole thing starts again. Took some time to find it out, and in fact the solution is very simple. Connect the reset pin to ground, to minus. Of course I could have found that in the data sheet, but anyway, I always like to do experiment. Here you see the final phase of that sequence. So now, well, there's another sequence, and after that the whole thing starts again. I also made a very simple clock circuit. It's a multivibrator here. The capacitors set the time of the clock with 2.2 microfarad. It's quick, 10 microfarad it's slow, and 100 microfarad is very slow. The transistors that I've used are the same, all the BC547B. I have used 3 other types of transistors, but every universal silicon transistor can work. Well, this is the complete schematic. Hope it's visible from this distance. And you can see that I've indicated the clock wire from the clock to the input pin. That is pin 10 of that HEF chip. And I've used here a 1 mega ohm resistor. I don't know whether that is necessary. Anyway, it worked better. So all the problems are solved. Now it's time to do better experiments, trying to get the best out of this chip, doing more exploring more ideas, And the first idea is of course a clock. And I don't know, when I have a 1 hertz here, that's 1 second, how much time it will take till that final output lights up. Perhaps I need a chronometer, a timer, etc, etc. Thanks for watching. It's stable enough now to go on. And I want to show the schematic again, because it is important. Thanks for watching.